Ryan with Miss.Geek here, and in this video we're going to start looking at some basic components of the DC40 build and how to physically lay them out so that they can be built on the W7RLF proto board. And because we need to know how big each component is going to be. So today we're going to look at the bandpass filter, and we're going to look at the double balanced diode ring mixer. So let's first look at what those parts are. So if you're going to build the bandpass filter as shown here, you just need one 5 microhenry toroid. So you can, I don't even know what that is off the top of my head, and a couple of capacitors. I'm going to use this. This is a QRP Labs. This one's a 15 meter, but I'm going to use a 40 meter bandpass filter, and I'm going to make it so that I can unplug it and plug a different band in easily, so I can switch bands. And I'll show you how I'm going to do that or why I'm going to do that in a minute. So we have this, and we can measure the size of this by just simply putting it on the proto board and leaving a little bit of extra room. We're going to say this takes 1, 2, 3, 4, 5 by 1 squares. So we're going to say 5 by 1 squares for this guy. And the antenna connects directly to the in, well, or out really, on this. And then so you got one connection to 2 connections to ground, and then the signal path, and that's it. The next thing is the double balanced diode ring mixer. And the double balanced diode ring mixer, they call it double balanced because there's a transformer on each end. So to put it simply, this part of the radio and this part of the radio all need to work at 50 ohms. But this ring mixer, this diode ring mixer, which is essentially a full wave rectifier, needs to work at 200 ohms. So to do that, we create a 4-to-1 transformer on both ends of it. So this steps up from 50 ohms to 200 ohms and back down from 200 ohms to 50 ohms. And this transformer here is 3 windings around basically 3 windings around a FT37-43 transformer toroid. And so basically, if you take 3 lengths of wire and twist them together, so you get about 10 twists per inch, and then wrap that around this toroid 10 times, you get this. So in each of you can see there's 2 sides. You can see that easily there. There are 2 sides to this thing. So the sides are arbitrary. You can call them left or right. You can call them side 1, side 2. Doesn't really matter. We just need to make sure that these 2 match, these 2 match, and these 2 match. So this wire going in on this side is the same wire coming out in the same position on the other side. And we'll make sure of that later with a continuity tester. But the schematic signifies that with this dot. So the dot signifies one side of the toroid. It doesn't matter which. So you can see there's a dot here, here, and here, but also over here there's another dot here, and another here, another here. So I labeled those A1, A2, B1, B2, C1, C2, D1, E1, so on. So that way I can easily draw it out and start working on how those all connect physically. And then you have the actual diode ring mixer itself. And this is just 4 diodes in series connected in a loop. And they're all facing the same direction, so to speak, electrically. So you can see this, if you were to view this as an arrow, the arrows all go in a loop. So how you physically build this loop doesn't really matter as long as the topology is correct. So if you were to take a physical square like this, imagine that each of where my fingers are touching is one on the side of a square, and you go like this. If you take that and you fold it over like that, you end up with this crisscross type stuff. So you have 4 diodes crisscrossed over each other, and that saves a lot of room, but also makes it really easy to connect the toroids or the transformer to the diode ring mixer, because we can see that B1 it goes here. I marked where each part of the transformers connect. So each transformer is connected to half of the the ring. And so, and it does matter. It doesn't matter which half, but you can't. Each transformer has to be separated by 2 diodes. So like E2 and D1 are separated by these 2 diodes, and B1 and C2 are separated by these 2 diodes. So and these 2 diodes. So you get the point. You can't just connect these 2 here and these 2 here and hope it will work, because it won't. So using this topology, like I showed, makes it real easy. So what I did is I drew this out. So the W7RL proto board, which obviously this is a blown up version and something I can write on, the diamonds are ground, and they're all connected by a ground plane in the back, which is something you really want with a radio. You want a nice ground plane. So judging by this schematic here, A1 connects to the antenna or to the bandpass filter. A2 connects to ground. So if we were to lay this out physically, let's say these are A1 and A2. A1 can go here, but A2 could actually just connect directly to ground. We don't have to connect it to this pad, then connect that pad to ground. We can run it straight to ground. So if we leave our leads a little bit long, we get some flexibility. So A2 goes straight to ground. B1, that connects to the diode ring, and we'll cover that in a minute. B2 also goes to ground, but it's, again, this is very conveniently placed. B2, just connect it straight to ground. C1 also goes to ground. So we don't even have to connect it to this pad, we can just connect it right here. I had shown how they're all 3 going to ground by connecting them here, but if you put this one here, this one here, and this one here, they're all connected to each other and to ground because of that ground plane. Now, here's the cool part. We have these 2 diodes going this direction, these 2 diodes going this direction in a crisscross pattern. And we can just take C2 and connect it right here. We can take B1. If we left it long enough, we could connect it right here, but we might need to run a little jumper and connect it right here. And now you'll notice that I've got the 1s on top and the 2s on bottom here. On this side, on this transformer, I've got it the other way. The 2s are on top and the 1s are on bottom. That way, D1 connects straight to D1. I could just take that and move it right on over here, connect it. D2 connects to E1, and I could just fold it under. So I could take, let's say this is D2 goes to E1, so I could take D2 and fold it under and connect it to D1. Or E1 rather. So D2 folds under. That makes the connection really easy. And then those connect to the amplifier, which is this stage right here. So this is the audio amplifier stage. And then F2 rather, we can just connect it directly to ground. Sorry, I'm getting off the page here. F2 connects directly to ground. And then F1 goes to the VFO, which we'll cover that later. In this schematic, it goes to this capacitor, but on the new version of the schematic actually goes to, here it goes to where is it? It goes to a 47 ohm resistor and then to the VFO input. So that's it. And now we know how big this is. So this is 2 by 5. So it's a 2 squares wide and 5 squares long. So we know this is 1 by 5. This is 2 by 5. So now we have an idea of how much room we have to work with. So we can start building basically. And what I'm going to do is I'm actually going to cut this out. Also going to make one of these similarly and cut it out. And then I'm going to work on building this, planning it out with one of these. I printed several of these. And just make sure when you build the audio stages here, the audio preamplifier, that you don't try to get fancy with it. Just build it simply and don't make the leads overly long, but don't worry about making them overly short either. It's going to work no matter what you do, basically. This is a very simple circuit. I tried to get fancy, and I made it so that it was impossible to work with. So when you build this, make sure you give yourself plenty of space here, so that if, let's say you put in one of the transistors wrong and it blows up, you can easily replace it. That's going to be something you want to do. So that the amplifier, the final audio amplifier, is going to be an LM386, and the easiest way to do that is just buy one of these boards. You can buy like three or five of these boards for a few dollars online, like AliExpress or something, probably Amazon. For a VFO, I'm going to use this VFO with this display. This is from my BitX40 project. Just going to reprogram it just a little bit to work with this. And then the nice thing is that this has the built-in ability to do multiple bands. And so that's why I'm going to have the ability to plug in different bandpass filters. And I might even do like switch out bandpass filters or something like that. QRP Labs makes all this stuff to do that with relays. I probably won't do that. I'll probably just do them, switch by hand and then switch the band here. So it'll be fun. It's gonna be a fun project. I'm looking forward to the rest of it. I hope that this has been informative to you and it gives you something to work with. And if I got any of this wrong here, and please feel free to correct me, because I probably did. Please feel free to correct me in the comments below. And I think that's it. So thanks for watching, and we'll see you next time. 73.